Okay, we are going to look at 6.06, our central angles. So the two main types of angles that we have in circles are our inscribed angles, which you will remember those are created by two chords and their vertex is on the circle. Now, if we look at central angles get their names because they are angles created by two radii, which is the plural of radius, whose vertex is at the center of the circle. So the reason they're called a central angle is because now the vertex of our angle is the center of our circle. All right, and a central angle is equal to the measure of its intercepted arc, which remember is the arc that it opens up to. So for example, if we said that this angle here was 48 degrees, then that means that the arc that it's opening up to, which if we outline this angle, it is opening up to this arc right here. So if the angle is 48 degrees, that means that this arc is also 48 degrees. They are always equal. So let's look at some examples. Looking at example 1, we are asked to determine the missing measure. So notice we are looking for the measure of this arc right here, and that arc opens up to this angle, which we are given is 41 degrees. Well, because this angle is a central angle, which remember, we know it's a central angle because its vertex is at the center of the circle. So because this is a central angle, then it is congruent to its arc, and therefore that arc is 41 degrees as well. And it works both ways, which we see in example 2. So notice in example 2, we are looking for the measure of this angle here. We recognize that this angle is a central angle because its vertex is the center of our circle. So that means it's going to be congruent to the arc it is opening up to. So if we look at the arc it's opening up to here, we see it's 95 degrees, so our angle is also 95 degrees. All right, because central angles are equal to their arc, sometimes we have questions that I like to think of as a puzzle, but the more that we do them, the more that you will see and recognize the patterns within the circles. But a lot of times we are going to be using the fact that our whole circle, remember, is 360 degrees. Make a note to yourself over here in the margin if you need to. Remember, all circles are 360 degrees, which means that all semicircles, which we'll be using a lot, are 180 degrees. So the whole circle is 360 degrees, half of the circle is 180. All right, let's look at number 3. We are asked to determine the measure of FEH. Remember that we think of an arc name as connect the dots. So this is our first point, this is our second, and this is our third. We have to go in that order. So we're going to start with F, then we're going to go to E, and then we're going to go all the way around to H. All right. Well, we know if we're looking for the arc, this whole entire orange arc. So we want this whole orange arc here. All right, well, we can look and see in the picture that from F to E is 65 degrees. We also can look and see that from E to I is 63 degrees. So we can add those together, and then to get the whole orange arc, we also need this purple arc as well. So if we add all these arcs together, we have now the whole orange arc. Well, I don't know what that purple arc is, but I do notice that it is opening up to this central angle here. So because 80 degrees is a central angle, its vertex is the center of the circle, that means that the arc is also going to be 80 degrees. So if I want my whole orange arc, I'm going to take 65 degrees plus 63 degrees plus 80 degrees, and that's going to give me the entire arc. So that entire arc, FEH, is 208 degrees. All right, moving on to example 4. Notice with 4 and 5, we are leveling up a little bit, so we're going to be given one circle and asked for a couple of different arc measures. So the first arc I'm asked to, which remember, this M right here, this stands for measure. So we want to know what's the measure of arc CD. Well, if I identify arc CD, which is this arc right here, it opens up to this angle here. Remember, this little box is representing a right angle, which is 90 degrees. Also, this is a central angle because its vertex is the center of the circle, which means that arc is going to be the same exact measure. So that orange arc, or CD, is also 90 degrees. All right, next we are asked to find the measure of arc FD. So this is where we're going to have to start using the concepts of our whole circle being 360 degrees and half a circle being 180. So if we look, FD is this entire arc right here. So we want this whole purple arc right here. All right. Well, I know that from here to here, F to E is 34 degrees. So I really just need the measure from E to D. So if I can find the measure from E to D, then I can add that to the 34 degrees. Well, notice here that if we look at what we just found, that 90 degrees, and that blue arc that we're looking for, this is half of our circle. So if that orange arc is 90 degrees, then our blue arc is also 90 degrees. We also can see that this is creating a right angle. So now to find FD, all I have to do is add 34 degrees plus 90 degrees. And I get the measure of 124 degrees. All right, what about the measure of arc DCF? So I want to highlight or outline. And remember, we have to go in that order. So I need to go from D to C all the way around here to F. All right, now there are lots of different ways for us to identify the different arc measures. So this is not the only way. You could have a different way that works just as well. But if I'm looking at this red arc that I'm trying to find, I notice that this is everything except for what I just found, which was FD. So that red arc is the rest of the circle that's not FD, which we just found. Well, I know that my entire circle has to equal 360 degrees. So if I subtract the purple portion, which we just found was 124, that's going to give me that red portion that I have left. So that is going to give me 236 degrees. So that is the measure of DCF. And then last but not least on this particular problem, we are going to find GDF. So we know this is 90, this is 90. Okay, so I'm going to identify or outline first. If I go from G, oops, sorry, to D, and then to F. Remember, we have to go in that order. So a couple of different ways that we could measure this. If we know all the other arc measures, so we know that our first arc we found, CD, was 90 degrees, then we had to find out that from E to D was 90 degrees. Also, notice that these two, oops, that was not what I was trying to do. Let's go. These two angles are vertical angles, so this is also 90 degrees. So we really could just add up all those arc measures. So we can add up 90 degrees plus 90 degrees plus our 90 degrees plus our 34 degrees. That's one way of doing it. There are, like I said, multiple ways to do it. And we would get 304 degrees. All right, let's do another one. And like I said, the more you do this, the more you will start to notice the patterns and get really good at it. That is how you get better, as you practice. So the first thing we want to find, now notice we're looking for an angle. So we want angle UXV. So I'm going to outline from U to X to V. All right, again, there's a couple of different ways that we can do these problems. What I am going to notice is that this green angle is a vertical angle, which remember vertical angles are congruent. It's a vertical angle with this angle right here, which opens up to 72 degrees. And because it's a central angle, it's also 72 degrees. So guess what our green angle is? 72 degrees. Look at all of our geometry connecting. All right, next we want to find the measure of ST. ST is this little angle right here. This little arc right here. Again, lots of different ways to do this. If I am looking at this circle though, what I am noticing is that because this angle here, 87 degrees, is a central angle and opens up to this arc, it is also 87 degrees. So now if I were to put all these arcs together, notice that I have a semicircle. I have half my circle. So if I'm just looking for this red portion, remember the whole semicircle is 180 degrees. I can take away my 72 and my 87 degrees, and that will leave me with the portion of that semicircle that's left. So I'm going to take 180 degrees, I'm going to subtract 72 degrees, and I'm going to subtract 87 degrees. And that is going to leave me with this little portion of 21 degrees. Okie doke. Moving right along. This will be so awesome. Okay, that's all right. Okay, next we want to find WV. WV. So I'm looking at WV here. And again, we have a lot of different ways that we can look at this particular blue portion of our circle. Remember, going back to the beginning, we said this was 72 degrees. Remember, because this is a central angle, it is congruent to the arc, so this is also 72 degrees. So that blue portion is really the only part of the circle that we do not know yet. So we could take our whole circle, 360 degrees, and subtract all the portions that we know. So we could subtract 72, we could subtract 21, we could subtract 87, and we could subtract our other 72. And that would give us the rest of our circle, which is that blue portion. So we get that our arc WV is 108 degrees. All right, and then lastly, we want to know what is TW. So ending on an easier note, TW, if we go from T to W, all we have to do is add together the two arc measures that we already know, which are 72 and 21. And we get that TW equals 93. So again, making sure we're still using all of those other characteristics of our circles, that the whole circle is going to equal 360 degrees, and half of our circle is 180. All right, as per usual, we do have a little bit of algebra. So notice the first thing that we want to find in number 6 is the value of x. All right, so I'm going to identify first, where is x? Well, x is in this arc here, and x is in this arc right here. What I'm going to notice is that these arcs, so arc AD opens up to this angle here. And I actually want to change this color. Arc BC opens up to this angle right here. All right, notice that these angles are directly across from each other, so that makes them vertical angles, which makes them equal. So if these angles are equal, guess what? So are our arcs. So that means that 8x plus 12 equals 10x minus 22. So again, just to reiterate, when we first look at the problem, we are given that x is in this expression here, which is describing this arc, and it's in this expression here, which is describing this arc here. We notice that both of these arcs open up to central angles. Those central angles are vertical angles. Vertical angles are equal, which means that our two arcs are also equal, so we set them equal to each other. Now, x is on both sides of our equal sign, so we would have to make a decision and as to which side we want to move it to. I'm going to move it to the right, so I'm going to subtract 8x from both sides. 8 minus 8 is 0. Bring down my 12 equals 10 minus 8 is going to give me 2, and bring down negative 22. If x moved to the right, numbers are moving to the left, so we add 22 to both sides. Opposite of subtraction is addition. So 12 plus 22 is going to give me 34. That is going to equal, we bring down our 2x. Negative 22 plus 22 is 0. Last but not least, we want x by itself, so the opposite of multiplication is division. 34 divided by 2 is 17, and our 2's cancel out, so x is by itself. So x is going to equal 17. All right, if we know that x equals 17, then when we're asked to find AD, which is our purple arc, we are going to plug x in 17 in for x. So I'm going to get 8 times 17 plus 12. And that gives me an arc measure of 148. All right, CD. Notice that CD is going to be this little portion right here. Well, if I take what I just found out, so if I take what I just found, which was our purple arc here, and what I'm looking for, CD, notice that that creates a semicircle. So together, they have to equal 180 degrees, which means if I just want this red portion right here, I can take the purple portion away from 180. So I'm going to subtract that 148 that we just found, and that's going to leave me with what's left, which is that little CD, what we're looking for. So we get 32 degrees as our arc CD. All right, and then lastly, if we want BDC, so I want to go, which I'm going to erase all this just so that we don't get too crazy confused. I'm going to leave our arc measures though. All right, so we found that AD, we found that that right here is 148 degrees. We already established that AD is equal to BC, so that actually means that BC is also 148 degrees. And then we just found that CD is 32 degrees. So remember that this angle and this angle are equal, and so their arcs are as well. Okay, so BDC, and I have to go in that order. So I'm going to go from B to D to C. So I want this entire blue arc here. Again, we have lots of different ways to look at this problem. If I'm looking at it, I'm noticing that I want everything except for that green arc, which I already know the measure of. So if I put the blue arc and the green arc together, remember all circles have to equal 360 degrees. So if I take away the green portion of that circle, that leaves me with the blue portion, which is what I'm looking for. So 360 minus 148 is going to give me 212 degrees. And that is our central angles. So central angles are equal to their arcs and allows us to use the other characteristics of circles to solve for angle and arc measures.